So it's one challenge with figuring out where number 6. Okay, what would be the traditional method of trying to find out where something, quote, starts? Plug in 0, right? But so what's the problem here on number 16? Can't really do that, right? You can't plug it. So this is not defined for t equals 0. So you can still answer the question though. Describe in words how the circle is traced out, including when and where the particle is moving clockwise. So clockwise, what happens when it's moving clockwise? What are some of the things that are happening when you're looking for the Cartesian version of this? What's the Cartesian version of this? Anybody have any ideas about how you can convert this to Cartesian form? What should I do, Josh?
So what I did,
I think you said move 2 over. So x minus 2 is equal to 5 cosine t, and y minus 7 is equal to. So then what did you do? Yeah, so now you know that x minus 2 squared plus y minus 7 squared is equal to what? 25, well, let's just write it out once first, plus 25 sine squared. I just added them together. But what can you factor out of the right-hand side? Cosine squared. And what is that equal to? So now you end up with x minus 2 squared plus y minus 2, sorry, y minus, not 2, y minus 7 squared is equal to what? 25. So what is that? Can someone describe that in words for me? To answer this one properly, you could sketch it a little bit, that'd be fine. You end up with something like this, and the center is 2, 5, but it's a parametric equation. It wants to know where it starts and which direction it's going in. As far as I remember, it starts right here at 7, 7, and it goes counterclockwise like this. It goes counterclockwise. We're both saying the same exact thing. So if t is less than 0, x is going to be less than what? X has to be less than 10, and y is going to be less than what? 0. That's all it's asking for right there for A. It's just asking what part of the line. You're getting the part of the line where x is less than 10 and y is less than 0. So you could graph this line and then delete everything to the left and below. That's it. That's all it's asking. B asks you, what part of the line do we get restricting t to 0 to 1? How would you describe the answer to this? Well, we have x is equal to what? 10 plus t. And y is equal to what? 2t. So we're going from 0 to 1. So how would you describe this? The segment going from 10, 0 to 11, 2. Exactly. Because this is when t equals 0, and this is when t is equal to what? 1. Yep. Out. So what do we have here? X is equal to 5 sine t. Sorry, 5 sine 2t, and y is equal to what? 4 cosine 2t. How do you algebraically turn this into a Cartesian equation? Do you remember? Yeah, we do. It's very similar. We isolate the thing with the trig in it. So we have x over 5 equals sine of 2t, and we have y over 4 is equal to cosine 2t, and then we square and add them together. So what do we end up with? X squared over 25 plus y squared over 16 is equal to
1.
Is equal to 1, yeah, because you get cosine 2t, sine squared 2t, and cosine squared 2t. So that's an ellipse. So when you graph this, what are the x-intercepts?
Positive and negative 5.
Yeah, exactly, positive and negative 5. If I can actually draw 5 there. And then you end up with 4 and negative 4. So you end up with an ellipse. Nice. But then it's asking you what direction is it going. You can plot some points and you figure out it is going clockwise. This thing is going clockwise. Nice. B asks, on this, we did this yesterday. We used this. We've used that before. What do? You know that dy dx is equal to, you differentiate y with respect to t, and you differentiate x with respect to t. So this just means it's dy dt over dx